all of the relationships that we use in physics to analyze how one variable changes when the other variables change, all those relationships work as long as the units are agreeable. That means that units will cancel out in the equations. But oftentimes you will have units that are given to you that will not agree with each other, and when that's the case, you have to convert the units before you do the problem. There's really two different methods that you can use to convert units. One of those is called the Monorail Method, and one of those is called the fraction method. I'm going to show you how those methods work through some examples. So the first example I'm going to show you is to simply just convert 10 kilometers to miles. Okay, you know, somebody says, hey, I'm going to go out and run a 10K. You may not know how many miles that is off the top of your head, but this conversion factor right up here would help you figure out how many miles that is. Whenever we take one unit and tell you what the equivalent value of it is in a different unit, we just call that a conversion factor. So the one that we use most often here is that 1 mile is 1.609 kilometers. I'm going to use that conversion factor in my problem to find out how many miles 10 kilometers is. So the first thing I'm going to do is start off by writing down what I'm starting with in the first place. I'm going to write down 10 kilometers right here. Okay, so this is the number that I start with. I write down 10 kilometers. What I'm going to then do is I'm going to multiply 10 kilometers by my conversion factor written as a fraction. I'm going to write the fraction like this because I want this kilometers that I started off with to cancel out with this kilometers that's in this denominator. Essentially, as you know, it follows the same rules of math. If you have something in a numerator, it'll also cancel out the identical thing in the denominator. Now what I'm left with in terms of units is just the term miles. The last thing that it takes for me to do here is to just perform the math, how it looks. I'm going to take the number 10, I'm going to multiply by 1, and I'm going to divide by 1.609. And when I carry out that math, I calculate 6.215, or rounding it, 6.2 miles. What I basically have said here is that 10 kilometers is equal to 6.2 miles. I arrived at that answer by dividing by 1.609. Many of you might have realized that that's what you needed to do, but this method really guides you into seeing that that's the proper solution. The method that I just showed you right here was called the fraction method. Okay, the Monorail method would look very similar with just a few small changes. On the next slide, I'm going to show you what the Monorail method is. Okay, so this example is another example that might be very easy for some people to figure out because we all kind of know like how to go back and forth between hours and minutes. It's a very familiar thing to you. But I want to use this example to illustrate what the Monorail method might look like. So as before, I'm going to start off by writing the information that I start with down below. But this time, instead of multiplying by a fraction, I'm instead going to first draw a monorail. So you might know what a monorail is. It's a single rail train. In this case, my rail is this horizontal line, and this represents one piece of the monorail. Sometimes you have multiple steps and you'll have more of these, as I'll show you in a later step. So I write this monorail so that the information I start with is in the top left quadrant of that monorail. And then what I'm now going to do is fill out the other side of the monorail with my conversion factor. This is a pretty familiar conversion factor to all of us. We know that 1 hour is 60 minutes. I'm writing it like this because I want the minutes in the denominator to cancel out the minutes in the numerator, or the minutes on the bottom of this monorail to cancel the minutes on top of that monorail. When that happens, I'll be left with hours on top, which is what I'm trying to get to in the first place. So really what I'm going to do here is take 312 times 1 divided by 60. And when I do that, the answer I come up with is 5.2 hours. So 5.2 hours is the same as saying 312 minutes. Okay, let's do another example that has a few more steps to it, and I'm going to illustrate how that would be done with both the fraction method and the monorail method, so you can see that essentially they're the same thing. Okay, so this example is a good example to look at because it's a little bit more unfamiliar units. People aren't necessarily sure what to do with everything. Also, this is actually a two-step conversion, which is a pretty common thing to do in a physics problem. So here's the problem. A Gatorade from the gas station is 20 fluid ounces. How many gallons is this? Well, if I look up some conversions between liters and ounces and gallons and liters, I can see this conversion right here, that 1 liter is 33.8 fluid ounces and 1 gallon is 3.8 liters. I can use these together to change the 20 ounces into gallons. I start off like before by writing down what I was given in the first place, and then using the fractional method, I'm going to actually multiply now by 2 fractional conversions. I'm going to first of all change ounces here by canceling it to liters, and then I'm going to change liters to gallons by multiplying by this fraction. What I now have left over is gallons on top, which is what I was looking for. The last thing to do is just to perform the math, which is to take 20 times 1 divided by 33.8 times 1 divided by 3.8. When I do that, I come up with this answer, 0.1557 with some more digits, and when I round that, it is 0.16 gallons. Now, if I was going to use the monorail method, it would really look very similar to this. I would start off by writing what I start with, and then I would draw my monorail lines, and then I would fill in the monorail my conversions. Now I'm not really thinking about them like fractions, more than I'm just filling in the conversion factors where they belong. Again, being careful to put the right units on top and on bottom so that I can get cancellation like so. You can see that the math I'm going to do is really going to end up being the same thing. I'm going to take 20 times 1 divided by 33.8 times 1 divided by 3.8, and I'll arrive at the same answer. I mean, these two methods, even though they have different names and they look slightly different, you can see mathematically are the exact same thing. Okay, in this final example, I'm going to show you how you will convert a more complex unit, particularly a speed or a velocity unit. Our two most common units of speed and velocity are meters per second and miles per hour, and this is a conversion that we do back and forth quite often. So this example will help you think through that. In the Olympics that just happened very recently, Usain Bolt ran the 100-meter dash with an average speed of 10.2 meters per second. You know, how fast is that in miles per hour? I want to basically convert the unit meters per second to the unit miles per hour. I'm going to need these two conversions to do that. 1 mile is 1,609 meters, and 1 hour is 3,600 seconds. I'm going to show you the fractional method, and hopefully you'll see that the monorail method is pretty much the same thing. So I start off by writing down my beginning information, 10.2 meters per second. Now notice the way that I wrote the meters per second here. Instead of writing it, you know, like this, like it looked in the problem, I ended up writing it as more of a fraction in the first place. That way it'll be easier to convert it, or to see how it converts through my process. So what I'm going to do is I'm going to multiply by a conversion factor that will change the meters in my original information to miles. So I have 1 mile on top and I have 1,609 meters on the bottom. If I stopped right now, I would just have miles per second. So I'm going to do one more conversion where I convert seconds to hours. I put the 3,600 seconds on top so that the seconds will cancel the seconds that's in the denominator at the very beginning. Now if you notice, I basically have miles on top, I have hours on the bottom. That's the unit that I'm looking for. Now it's just a matter of carrying out the math. 10.2 times 1 divided by 1,609 times 3,600 divided by 1. When I do that, I come up with 22.82 rounded to 23 miles per hour. You know, 10.2 meters per second is pretty darn fast. I challenge any of you to try to run side by side with a car going 23 miles per hour. It's not going to be very easy to do. Well, hopefully this little video helped you to understand the unit conversion process. Really, you're just going to have to do a lot of practice to get good at this. So I wish you luck, and I wish you to have a great day.